Dear students, welcome to the first lecture of our multivariable calculus series. In this series, we'll be exploring the fascinating world of calculus beyond single variable functions, where things get more dynamic and complex. We'll delve into functions that depend on multiple variables and tackle the mathematical tools that help us analyze and solve problems in multiple dimensions. You might already be familiar with single variable calculus, where we deal with functions like y is equal to fx, but in real world problems, we often encounter situations where a function depends on more than one variable, such as forecasting the weather involves recording ongoing measurements of temperature, pressure, precipitation, wind speed, etc. Cost of painting depends on both the paint I choose and the area I want to paint. Similarly, the amount of petrol spent depends on my choice of vehicle to drive, type of petrol I choose, and distance I need to go. Last but not the least, in culinary sciences, the science of flavor consistency across restaurant chains also depends upon several variables like temperature and pressure while cooking and time spent on cooking apart from the ingredients and their ratios. So this is where multivariable calculus comes in, enabling us to understand, analyze, and optimize these complex relationships. So in this course, we turn our attention to functions of several variables, extend the basic ideas of calculus to such functions. We expand our understanding of functions of several variables, partial derivatives, gradient vectors, multiple integrals, and more. So it's like moving from a 2D world into 3D, where we no longer deal with just curves, but also surfaces, volumes, and complex geometric shapes. Whether you are a physicist, engineer, economist, computer scientist, or data scientist, multivariable calculus gives you the language to describe how things change and interact in space. So in this course, we'll be following Calculus by Anton, and we'll cover chapter 11, which is about three-dimensional space and vectors, chapter 12, about vector-valued functions, chapter 13, which describes partial derivatives and related results. Chapter 14 is about multiple integration, and topics in vector calculus will be discussed in chapter number 15. So that is all for today's video. This is an introductory video. So we'll formally start the course in next video, in which we are going to cover section 11.1 from chapter 11. Till then, take care. Bye.